So this is another question on the past trial examination, September 2021, grade 12 mathematics. So we have the word pandemic. So let me just write down the word. We have the word pandemic. And then 12.1 is saying that how many unique arrangements of the letters can be made, right? How many unique arrangements of the letters can be made? So let's look at our word. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different letters. And how can we arrange these 8 different letters? So let me create spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8. So in the first position, there's 8 possible letters you can put in the first position when you're arranging the letters. So we have 8 possible ways in the first position. And then in the second position, because you've already placed one letter, you have 7 positions, 7 letters that can fill that position. So we have 7. And then on this third position, you have 6 letters that you can put in that position. You can see the trend now. So here you're gonna have 5, 4, 3, 2, 1. So basically you have 8 factorial ways which you can arrange these 8 different letters. And then 12.2 says determine the number of unique arrangements of the letters that are possible if each arrangement must start with the letter P and end with the letter C. So fine. Let's have 1, 2, 3, 4, 5, 6, 7, 8. Right? On the first letter, they're saying that let's start with P. It's a must. And then on the last letter, let's have C. It's a must. How many ways can you arrange the letters in this word if the first letter is P and the last letter is C? So here on the first position, we only have one possible letter, which is P, right? So we have 1. And then on the second position, there's 6 possible letters because of the 8, 1 letter is in position 1 and then 1 letter is in the last position. So this second position, we have 6 possible letters that we can place there. And then on the second position, we have 5 possible letters because we have exhausted 3. And then on the fourth position, 4, 3, 2, 1, right? So we have 1 multiplied by 6, 5, 4, 3, 2, 1. So that's basically 6 factorial. And then the last letter is C. We only have 1 C. So that will be 1. So 12.2, we have 1 multiplied by 6 factorial multiplied by 1. Right? This one is because the first letter has to be P and we only have 1 P. And then this one, the last letter has to be C and we only have 1 C. And then the letters in the middle, we have 6 letters remaining and 6 positions. So we can arrange them in 6 factorial ways. And then 12.3. Calculate the probability that randomly chosen unique arrangements of the letters will start with the letter P and end with the letter C. So the probability of an event A is equals to the number of possible ways event A can occur divided by the sample space. What is the number of possible ways that the arrangement of letters can start with P and end with C? That is the answer to 12.2, right? 1 multiplied by 6 factorial multiplied by 1. But then what are the possible arrangements of the letters if we don't have any restriction? If we don't have any restrictions, we have 8 factorial ways we can arrange the letters. So we basically have 6 factorial divided by 8 factorial. And that is equals to 1 divided by 56.